So the purpose of this video is simply to provide a number of examples of the way that we have to compute averages for the AP exam. What these all boil down to is either that you're finding the average value of some function or the average rate of change of some function. So in the previous video we talked about sort of how to tell the difference between those two things, and now we're just doing examples of that. So the first example, use your calculator to find the average velocity of a particle on that interval if the velocity function is that. So it's interesting. The question is asking us to find the average velocity and then giving us the velocity function. The easiest way to do this is then to find the average value of the velocity function. Average of velocity could be found by finding the average rate of change of position, but I don't have a position function, so this method is going to make a lot more sense. Right? So at this point I'd say pause the video, make sure that you know how and what it means to find the average value of that function. You might even just want to write down the expression that it's going to take, and if you got a calculator you can use it, otherwise you can just see what I'm going to do. So finding the average value of this thing means we do 1 over 5 minus 1 times the integral from 1 to 5 of the thing that we want the average value of, in other words v of t, so that would be t sine of 3t minus 1. And if I plugged it into my calculator correctly, I found that that was negative 0.089. And that is the average velocity of this particle. Right? For as much as the problem didn't say find the average value of the velocity function, we interpret this to mean the average velocity to be the average value of the velocity function. So next example. A child is running back and forth along a straight path. Their position at time t is given in the table below for various values of t. Find the average velocity of the child on the interval from 0 to 60. So this question, understand, is asking the same thing. It's asking you to find the average velocity. So again, we have two possible options, right? We could either find the average value of a velocity function, or I could understand that velocity means the rate of change of position. I'll say that again. Remember that velocity is the same thing as the rate of change of position. So asking for average velocity is the same thing as asking for the average rate of change of position. Well, in this case, I'm given a position function, so trying to find the average value of the velocity function just doesn't really make sense. It makes a lot more sense for me to compute this average velocity by finding the average rate of change of position. And I should mention, if that's not clear, like pause, rewind, like listen to that again, process that again, and make sure that you're understanding it. So I'm going to find the average velocity by finding the average rate of change of position. I do that by doing p of 60 minus p of 0 over 60 minus 0. I've got a table right here, so I just extract these values. P of 60 is 40. P of 0 is 10 over 60. That ends up being 30 over 60, which is 1/2. So the average velocity of this child is 1/2. And I didn't give units here, but that's the idea. That's where it comes from. So in the next example, I'm giving you a graph of f. So here's the function f, and you're asked to find the average value of f of x and the average value of f prime of x. Okay? So we begin needing to find the average value of f of x. And in some sense, that's a really straightforward question. It says find the average value of f of x. You guys have sort of memorized. That's 1 over 10 minus 0 times the integral from 0 to 10 of f of x dx. Because this is a graph of f of x, we should be able to do this kind of by computing an area, right? This thing here is a triangle that's 4 by 2, so that means this area here is negative 4. Here's another triangle whose area is 4. Here's a rectangle whose area is 5 by 4, so this is 20, and you've got a little leftover rectangle here that's 4 units by 1 unit, so this has an area of 2. So that means this overall integral is 22. I've got 22 times 1/10, which leaves me with 2.2. So the average value of this function is 2.2. By the way, that answer makes sense, because you can look at this and say, well, yeah, sure. I mean, this is sort of saying that this is the average height of all of these points. That's 2.2-ish. I think that's actually 2.4, but whatever. If you look at all of these values, 0 and up to a value of 1 and up to a value of 2 and up to a value of 4, 4, 4, 4. If you sort of added up all of these values and averaged them all out, you'd come up with an average value of 2.2. The second part of the question is a little bit more complicated. They're asking us for the average value of f prime of x, right? This would be easy if I had a graph of the derivative, but I don't. It might be difficult for us to sort of use the same method we did before. So this is sort of where we say, well, wait a minute. Remember what f prime of x is. Remember how f prime of x can be read. We can read it as f prime of x. We can read it as the derivative of f. We can also read it as the rate of change of f. So this question effectively is asking for the average, well, I suppose I should say it's the average value of the rate of change of f of x. So even though this problem looked like an average value problem, because it was asking for the average value of the derivative, we can make it an average rate of change problem. Right? So we find the average rate of change of something by looking at f of 10 minus f of 0 over 10 minus 0. Let's see here, f of 10, if you look at your graph, f of 10 is 0. F of 0 is negative 4 divided by 10. So this ends up being 4 over 10, which is 0.4. So the average value of the derivative function is 0.4. Even though we didn't have the derivative function, we were able to come up with the average value of that thing by looking at it as the rate of change. So then in this last example, we have that a tree grows at a given rate. So there it is, r of t is 4 root t minus t meters per year. I want to find the average rate of change of the height of the tree on that interval. So again, you got to watch out. These problems are tricky. This problem says, "Hey, find the average rate of change of something." And you're like, "Yay! I'll use the rate of change, thing." And you could go about it that way, but I sort of look at this and say, "Well, wait a minute. They gave me a rate function. This is a rate. So if they're asking for the average rate, they're effectively asking for the average value of the r of t function." And I hope that makes sense, right? They gave us a rate function, they're asking for the average rate of change, so they want the average of that. They're not asking for the average rate of change of r of t, they're asking for the average rate of change of the height, the average of r of t. So to do the average value, we're supposed to do the integral, 1 over 4 minus 0, times the integral from 0 to 4 of this function. And this is one that we can do by hand. And if you want some practice with integration, if you've got brain power left, pause the video, walk through this antiderivative, make sure that you can do this basic process in addition to understanding the concept. So let's see here. I've got a 1/4 out front, and I'm really going to largely ignore that for a while. The integral of this thing ends up being 4 times 2/3 times t to the 3/2 minus 1/2 t squared, evaluated from 0 to 4. Again, 1/4 out front being ignored. This is 8/3. 4 being plugged in here means I'm doing 4 to the 3/2 power. The half on the bottom takes the square root of the 4, makes it 2, and then 2 cubed is 8. So times 8. If that didn't make sense, then pause, work it out on the side, and make sure you're okay with that. Minus 1/2 times 16, which is minus 8. So then moving along, this is 1/4 times 64/3 minus 24/3. 1/4 of 40/3, which is 10/3. And that's our answer to the problem. That's all the examples that I had. I hope that makes sense. And the point that I really sort of kind of wanted to get across that I mentioned in the first video is this ability to calculate the average value of things and recognize whether it's an average rate of change or average value shows up pretty often on the AP exam. So it's something we want to make sure that we're comfortable with. So hope that made sense and that the assignment makes sense to you guys.